Okay. Hi, Sydney. So here's the box method for factoring a trinomial. And I'm going to just go ahead and make this equal to 0 so it looks like the problems that you were doing. So first thing I'm going to do is I'm going to factor out a common factor if there is one. And in this one there is. I can factor a 3 out of everything. So I'm going to divide out that 3, and that leaves me with 3k squared plus 22k plus 7. Okay, and then what I'm going to do is I'm going to take the first term and the last term and multiply them together. Or actually, what I'm really doing is the coefficient on the first term and the last term. So 3 times 7 is 21. And so what I want to think of now are two numbers that multiply to make 21 and add to make 22, the middle term. So that's the part that's kind of similar to the way that you were probably doing it in class. And I know that if I multiply 1 times 21, that would give me 21, and if I add together 1 plus 21, that would give me the 22 in the middle term. So those are the two factors that I'm going to use. I'm going to use 1 and 21 as my two factors. So now what I'm going to do is I'm going to make a little box like this, and I'm going to divide it up into 4 sections. And in the upper left-hand corner, I'm going to put the first term of the trinomial. So I'm going to put 3k squared. And in the bottom part, let me make that look better. That looks like a 5. In the bottom right-hand corner, I'm going to put the last term of the trinomial, which is the 7. And then in the diagonal, I'm going to put the two factors that I came up with that multiply to make 21 and add to make 22. And it doesn't matter which order I put them in. They just have to go in the upper right and lower left-hand corner boxes. Okay, so now what I'm going to do is I'm going to look across each row, and I'm going to look across each column, and I'm going to take a common factor out of each row and column. So like if I look at this top row here, the common factor of 3k squared and 1k is just a k. So I can divide a k out of both of those. And then if I look at the bottom row, I've got 21k and 7, and I can divide both of those by 7. So I'm going to put 7 out here. And then if I look at the first column, I can divide 3 and 21 both by 3. And I can divide k squared and k both by k. And then looking at the last column here, I can divide 1k and 7 really by, well, the only thing I can divide by is 1. That's the only common factor that they have. And then the other thing that I'm going to do is I'm going to put a sign in here. And really the signs on the number are going to be the same as whatever they're closest to in the boxes. So like because 1 is next to the 1k, which is positive, I'm going to put a positive in front of it. And because the 7 is next to the 21k, which is positive, I'm going to put a plus between the k and the 7. And so these two numbers here now on the outside of the box are your two factors. And actually, the other thing I don't want to forget about is that original 3 that I factored out. So the factored trinomial will be 3 times 3k plus 1 times k plus 7. And you can multiply that back together to double check that. And that is still going to be equal to 0. And then to solve this for x, or in this case I'm solving it for k, what I'm going to do is I know that anytime, the only way I can multiply and get 0 is if I multiply by 0. So that means that either k or 3k plus 1 has to be 0, or k plus 7 has to be 0. So what I'm going to do is I'm going to kind of figure out what would have to be true to make either of those 0. So for 3k plus 1 to be 0, that means 3k would have to equal -1. And then I can divide both sides by 3, and I get k equals -1/3. For k plus 7 to be 0, I can just subtract 7 from both sides, and k would have to be equal to -7. So those are going to be the two solutions to the equation here. Sometimes you see it written as and you probably know this, but you would just write k equals negative 1/3, comma, 7. Those would be my two solutions. Okay, I'll run through one more equation here with the box thing, just so you can see how that works. Let me find one here. Another problem. Let's do this one. Okay, so so here's another one to look at. This one doesn't have a common factor to take out, so what I'm going to do is multiply the first and the last. So 2 times 2 is 4. And again, here what I'm looking for is then two numbers that multiply to make 4 and add to make 5. And that's going to be 1 times 4. So the factors are going to be will be 1n and 4n. And so when I set up my little box, I put 2n squared and 2 and 1n and 4n, and then I start looking for kind of the common factor. So in the top row, I can divide an n out of both of those numbers. In the bottom row, I can divide them both by 2. In the first column, I can divide by 2n, and then in the second column, they really don't have anything in common, so I can just divide by 1. And then again, the 1 is close to a positive 1n, so I'm going to put a plus in front of that. The 2 is close to the positive 4n, so I'm going to put a plus in front of that. And so now my two factors are 2n plus 1 and n plus 2. Okay, and this, again, will make this equal to 0 so that it looks like the equations that you're doing. And so now, same thing, I'm going to figure out, well, 2n plus 1 could be 0, or n plus 2 could be 0. And if that's, so for 2n plus 1 to be 0, I'll subtract 1 from both sides. I get 2n equals negative 1. Divide both sides by 2. And so n would be negative 1/2. And for n plus 2 to be 0, n would have to be negative 2. So that's how you get the two solutions there. I hope that this method works well for you. You could also search, I think, on Khan Academy. There might be, I'm not sure if he shows this method or not, but he's got some good videos on factoring trinomials. And then I'll look and see if I can find another example of this too, so that you have another example to refer to. But hope this helps. Good luck. If not, let me know. Thanks. Bye.